Hey guys, my name is Noel. I'm doing a follow-up video to a video I made which explains a little bit more depth the procedures that I went through in order to develop my theory. What I did was I studied the isotropic vector matrix and how closest packing unit radius spheres and the vectorial interconnections between those, create numerical interrelationship patterns which are extremely exquisitely similar to those which are found within the nucleus of the atom. Now, on the board here I have some formulas which physicists and scientists do not currently have access to. They have not studied the isotropic vector matrix the way I have to understand the exact number of interrelationships. So you getting that in there? That's all good? Okay, thanks, buddy. So, I guess to start off with, since I've already made the other video, it's about 50 minutes long, a little bit slower where I go over a lot of the information. I want to kind of do this because I know physicists, you guys, your time's real important. You're not trying to listen to a bunch of silly shit, so I'm going to go over some things. Hopefully you'll understand real basically. Now, on this top portion of the board, I'm going to basically then explain when you take the mass of the neutron, 1838.5, multiply it by 2, second power it, subtract the mass of the electron, divided by the total number of angular degrees on the surface area of the tetrahedron, you come up with 0.00729, excuse me, when you take the inverse of the second root of the mass of the neutron times 2 to the second power minus the mass of the electron divided by 720 degrees of angular variation in the tetrahedron, you get 0.007297475. Real close to the fine structure constant. Code A says it's 0.007297352, a difference of 0.000000123. What we're finding then is this translates into Planck's constant times 10 to the 40 plus the inverse of the fine structure constant times 10 to the third minus the mass of the proton divided by the total number of angular degrees in a circle. Once again gets our fine structure constant 0.007297. In my other video I explained a lot about the different three scales I made, the alpha, the pen, and the quanta scale, and how they ratio. So 1 divided by my first quanta scale's 0 point, divided by 360 degrees, once again is our fine structure constant. Some other relationship patterns which I found, which may not currently be understood by physicists, and as I mentioned, exquisitely close. So if you could please then forgive me, 1 divided by the fine structure constant to the second power minus the mass of the electron divided by 2 is equal to 10 times the proton's mega electron voltage. So that's really interesting. 137 to the second power minus 1 divided by 2 equals the proton's mega electron value times 10. Now, what's cool about this, and this is what made my deductions so interesting, is that these numbers are based on models, wherein the exact number of interconnecting, vectorial, push-pull, attractive, repulsive forces are calculatable. I'll show you some models in just a second here. Basically then, the total number of vectors or energy connections between closest packed spheres, or the interconnection points which stabilize those vectors, in the 136 frequency tetrahedron is 1 divided by fine structure constant to the second power minus the mass of the electron multiplied by the inverse of the fine structure constant. And that equals the proton's MeV times 10 times the inverse of the fine structure constant. The total number of vectors in that 136 frequency tetrahedron are 2,571,216. Now I began to do my investigations further, and in my other video, like I said, I explained how number patterns work, how 17 and 23 revolve around the 137 until they meet up at this 9,384 point. So other number patterns run this way also. You've got 613 and 919 who revolve around a number, these are all prime numbers by the way, the prime number 3,677. And when you get to this quanta scale 0 point, we find that in the 3,676 frequency tetrahedron, there are an exact number of vectors. There's exactly 49,714,246,056 vectors interconnecting and stabilizing that system. And that's equal to Planck's constant times 10 to the 40 plus the inverse of the fine structure constant times 10 to the third minus the mass of the proton times the mass of the neutron times 4. That's the exact number of vectors. That translates to, here's a transformation formula then where we see the differentiation then, where we take the mass of the neutron times 2 to the second power minus the mass of the electron divided by 2 times Planck's constant times 10 to the 37th power plus the inverse of the fine structure constant times 10 to the third. Once again, this equals 49,714,246,056 vectors. Real quickly then, just so you understand what vectors are, energy components between closest packed unit radius spheres. When you create these large structures, they have exact numbers of spheres interconnecting them. Polyhedrons, such as a tetrahedron, truncated into the truncated tetrahedron, truncated again into the octahedron, truncated into the tetracadecahedron, then truncated into the cube, shown here. I discussed that more, so I'm going to move on then. I want everybody to understand then, basically, each of these connection points does not necessarily have to be a ball closest packed or a sphere closest packed. It's an energy connection point, a hold and stay station, a stabilization point, wherein the vectorial energy has a gravitational pull or a tensile integrity at its corners vertexes. These structures then can become much larger and larger. Bucky liked to use models. These then can operate as models in order to understand wave propagation expansion, beg your pardon, and contraction, so that the expanding and contracting wave propagation model replicates then the continuity and discontinuity in the universe, the seemingly continuous wave propagation field and the discontinuous particle field. Bucky says that in Synergetics 964.31, in the quantum and wave phenomena, we deal with individual packages. We do not have continuous surfaces. In Synergetics, we find the familiar pattern of second powering displaying a congruence with the points or separate little energy packages of the shell arrays. Electromagnetic frequencies of systems are sometimes complex, but they always exist in complementation of gravitational forces, and together with them provide rational integer characteristics of all physical systems. Little energy actions, little separate stars. This is what we mean by quantum. Synergetics provides geometrical conceptuality in respect to energy quanta. Now, Bucky talks about how modern physics doesn't use models, and it's difficult, especially for students, to understand difficult and abstruse concepts based on abstruse mathematical considerations. So he liked to make models. There's a difficulty in understanding what's called parity and complementarity. So I just want to explain real basically then a little bit about, for instance, how the concave interior of a structure and its convex exterior create a pairing of disparate properties. The external convex shape will impinge energy away from it. The internal will keep the energy bouncing around inside. One conserves energy, the other annihilates energy. These disparate properties of convex exterior and concave interior then act in complementarity to each other. They're not mirror images. Once again, you have the tetrahedron added to the octahedron, not mirror images, but pairs of disparate complementary polyhedrons, which then enclose all space. So it's a parity of disparity, creating complementarity and filling all space. Now, the seeming continuity of wave phenomena and the discontinuity of particle phenomena can be reconciled by understanding these models. The seeming disparity is based on a misunderstanding of complementarity. I'll show you then real basically how we can take one of the great circle planes of the vector equilibrium, take four of them. We take one and we can bend it into a bow tie figure, a Lissauges figure 8. You can take these then, four of them, the four great circles of the vector equilibrium, and you can combine them together in order to make the vector equilibrium, whose four planes then become reconciled as the four Lissauges strips are put together. Now, in the world of electromagnetic, we find then that the seeming continuity of wave propagation and energy cycling is only because at the infertunable levels, is due because of the infratunable levels. We cannot sensorily apprehend it with our mammalian sensory organs. But what we'll see here then is that a continuous cycling of energy along the Sauger strip then has to come up to a certain amount of volts in order to, in accord with Ohm's laws, overcome that gap. So the gap phasing then, once the volts overcomes the capacitor's resistance, creates that seemingly continuous to human minds continuum of flowing energy, seen through, for instance, copper molecular structures. As the energy is cycling over it, it can either stay shunted in this figure 8, or if it has enough energy, it will gap phase, jump the gap from continuity to discontinuity. It's a model from one sphere to the next. Keep in mind then that this is a nice model, even though there are many more great circles which are available for us to explore later. Any vertex or sphere of the system, any vertex, can be seen then as these energy units are coming. They all have plenty of room to take the different great railroad tracks of energy cycling around the halvings of the great circles of the various polyhedrons, which constitute the vertexes of the system. When you push the center of gravity of this tetrahedron, when you push the 4 faces of this tetrahedron to its center of gravity, those 4 planes then become the 4 planes of the vector equilibrium, the basis of the metric within the isotropic vector matrix. This continuous and discontinuous behavior in the universe then is also displayed right here in the tensegrity icosahedron, where you have discontinuous compression struts, which then are complementary to the tensional field embracing it. It's a continuous tensional field, and it is a discontinuous strut membership of these energy struts, which acts in complementarity to each other in order to create a unified field of parity. Now, Bucky's got a lot of models. You have to look in there because the particle to wave expansion and contraction models that he uses are excellent. I may have already showed you this, but what I want to show then is I'm going to digress for just a minute, explaining 2 things here. One, we saw then how the triangular faces then all close down into that octahedral phasing. I want you to look real closely then at this tensegrity icosahedron straight from above, and you'll see then how there's a minute triangle at its center. This is a particle plane, then has the potential to phase slip down involutingly, do a 180-degree spin twist torquingly, and then ending up in this alternate phasing of triangle where this vertex then ends up here, this one ends up here, and this one ends up here. So that spin shift phasing then creates a phenomenon in the universe where the continuity of those planes then becomes discontinuous, disintegrates potentially, creates waveform, and then back into that particle formation. Various models, and once again, I explained in the other video about how many total number of vector and volume associations, I don't need to pick this up again, are on the triangular face of the 17 frequency polyhedrons. So these have 918 vectors surrounding 919 volume. When these then compact together, the 17 frequency hexagon has 919 closest packed spheres around 1 for 918 spheres around 1 for a total of 919. So it shows a model by which the energy components of vectors and volume can squishingly turn into that 919 field of closest packed spheres and then come apart to the other side and become then that phasing of vectors and volume. In my other video, then once again, I explained then how those numerical interrelationship patterns with the squares 17 frequency plane exhibiting 613 spheres on that plane with 612 around 1, creating then a modality of operation wherein the 919 or 918 around 1 and the 613 or 612 around 1 create a ratio with the 6 planes of 613 and the 8 planes of the 919, creating an 1838.5 to 1836 complex. What's neat also that I don't mention in the other videos, that when you have that 17 frequency hexagon, you have 102 closest packed spheres around 1734 triangular spaces. 1734 plus 102 is 1836. Once again, just coming up with that interesting numerical interrelationship pattern which exists. And maybe just finishing up here. Christian, can you remember that I was going over anything that I didn't go over so far?
As far as I know, I think you hit.
Okay, let's just go ahead to the end. Like I said, I want to be quick for these guys.
Sure.
They have that, they can see that. What I'd like to explain then is how these point measures that I found, I call them the alpha, the pen, proton, electron, neutron, and the quanta scale 0 points, emulate a modality of compaction and condensing, which we can observe and understand. So when these frequency measures get really large, the total number of closest packed spheres and their total number of vectorial interconnections and the total number of volumes become, this one doesn't work, become very interesting. At the very highest levels then, which I can't compute, we'll need to then do some further investigation. But for instance then, the cube structure within the vector equilibriums framework and the isotropic vector matrices framework, at the 9,384 frequency, this cube has exactly 137 to the 6th power plus 1 divided by 2, total number of spheres or vertexes. It also has exactly 1,836 times 92 times 92 times 137 times 137 times 68 total vectors. Mass of the proton, total number of naturally regenerative chemical elements, inverse of the alpha scale. This is the total number of vectors, or kissing points between spheres. The total number of volume, I'm not going to write it down, 1836 times 92 times 92 times 92 times 51 times 2, 0.51 megaelectron voltage for the electron, times 136, that's the total volume. So in the next one, when you get to this is the alpha points first measure, they continue to double. These numbers continue to become interesting patterns, replicating those we find in the nucleus of the atom. My next 0 point of the Penn scale then, or the first 0 point of the Penn scale, 422,280. This cube then has exactly 919 to the 6th power plus 1 divided by 2 total number of spheres. It has 1,836 times 1,836 times 92 times 92 times 1,838 times 918 times 5 total vectors. So you can see the compaction of these ratios which we're seeing within the nucleus of the atom compacting themselves is still visible and evidenceable so that we can understand they're relating the same types of interrelationship patterns that we're finding in the nucleus of the atom. So in my last point then, in that last scale, called the quanta scale, the cube at 6760164 frequency has exactly 3677 to the 6th power plus 1 divided by 2 total number of vertexes. Remember, that's 1838.5 times 2. That's the total number of vertexes. The total number of vectors, 1838 times 1838 times 1839 times 1839 times 7354, which we'll remember is 1838.5 times 4, or it's 6625 plus 729, Planck plus alpha, the fine structure constant, times 7354 again, times 3. total number of vectors. The volumes follow suit. 1838 times 1839 times 1838 times 1839 times 1838 times 1839 times 729, fine structure constant times 10 to whatever, right? Times 3 times 2 to the 12th power. So these numerical and geometrical relationships could all be considered to be coincidental, or these coincidences could be considered to be the exact coinciding numerical and geometrical relationships which exist within the realm of the isotropic vector tensor energy spinning transformation matrix, which develops as a natural result of closest packing unit radius spheres. But he says, proofs must proceed from the minimum whole system to universe and the differentiation out of universe of the special case conceptual system. Proofs must start from the minimum something, that is the minimum structural system. All geometrical and numerical values derive from fractionation of the whole. So we can see then in how fractionating the tetrahedron at various frequency measures, we get these very interesting numerical interrelationship patterns. If this work interests you guys, visit my other work, listen to that. Go ahead and get in contact with me. I'm happy to come to your university and lecture or explain things that might need to be explained in a little bit deeper fashion. My book's not published yet. Happy to have any kind of help anybody's interested in giving me. If this work interests you, like I say, it's been a pleasure communicating with you. You guys take care.